Yeah, my only point of the sun was you guys asked like how does it work? Like I don't think anybody knows. We can tell you its path, what it appears to take, maybe from one location, but from multiple locations, it becomes more uncertain where it is. I mean, it's within a range. You know what I mean? It's not like way off, but it's off a little bit. So it's hard to draw conclusions when you, with a certainty, geometrically position where it is at all. This is
What
in the
about
gold model. So
Yeah.
people have done this in AutoCAD. Seriously, people have like taken went to time and date in SunCalc and took those elevation angles and tried to intersect at where they said the sun was supposed to be, and they could never get it to work in AutoCAD, which is like 8-digit precision.
what about like the moon?
The moon?
Yeah.
I don't know.
You don't know?
I don't fucking know, man.
Hey,
I mean, these are things we can never really know the true causes or what they do. They're intangible to us. All we can do is look at them.
But there's an explanation to it already.
I mean, but they're not really scientific explanations.
They are actually.
So why are they better than the stories that they were told? What the moon and sun were before? Why are those worse stories?
Wait, what?
Before the Copernican model, right? They told stories about what the sun, moon, stars, all that shit, where they had convoluted stories about what they were. So why is that any different? They couldn't touch the sun. The only thing they've done that's different is they've said, this is mathematical. We can make predictions. Our story's right because we can make predictions because we've attached to the variables, we've attached names, places, things called physics. You know, there's a guy named Oliver Heaviside, and he was a self-taught mathematician. He invented vector analysis, and he tells it. He starts one of his books with this little story. Says it was once a joke upon a mathematician when he took his symbols for realities as S for the sun and M for the moon, meaning the variables and equations are not the realities. We can predict things with, you know, motions of bodies, motions of objects, and all sorts of physical events, but it doesn't mean the underlying theory which we attach these variables to is correct or true.
But like at least,
and I can
like
give you a literal example of this with the Mayans. Now the Mayans predicted the transit of Venus better than the Copernican model, better than any other model. But their story that went with their prediction was Kublai Khan, who was a dragon, right, was going across the sky. So because their predictions are better, should we believe the Mayan story of why Venus is transiting the sun at this particular time?
Wait,
you see what I'm saying? Do you understand what I'm saying? Like they had a story, they had math, they had predictions. They had a different story, which we find implausible.
But like, what do you have? You just say like you don't know, and it's like that's all you're saying basically.
Because I'm taking a position of natural philosophy.
Okay.
But what about
the only thing you can say that is empirical and really know are things you can deduce from systematic experimentation and determining cause and effect relationships.
What about solar eclipse? How is that possible? Yeah.
Well, what do you mean possible? It happens, so it's possible.
No, how is it possible with like the flat Earth grid? With
what makes you think that the solar eclipse is associated with the geometry of the Earth? What is the connection?
I'm confused.
What makes you think that is connected to the geometry of the Earth? What is the connection? What's the logical connection? Okay, there's just the sun's in the sky and a black thing goes over it and it turns black. Where's the logical connection between that observed phenomenon and the shape of the Earth you are on?
That's what I'm asking. Like, what are you trying? What point are you trying to make?
It's like on.
I'm trying to make the logical connection, dude.
No. Wait,
you're
on
acting
the model.
like the shape of the Earth has to have some relationship to that event. Why does it have to have a relationship to that event?
I'm trying to explain it. Okay.
Okay.
So, in the model, you see like the moon and the sun circling, right? And they like never get near each other or nothing, right? And how is it possible for like the sun to like overlap the moon if it's like that?
Okay. Let me ask you one thing.
Listen, I don't know if Wretch, are you on?
Why doesn't everybody see the eclipse at the same time?
Wretch actually has. Listen, Wretch actually has a model that demonstrates it.
And it's a globe. And if you're on the other side of the globe, you're like, you can't see it because,
exactly.
You know,
I'm just trying to argue my side of the story. So, if you're saying that the eclipse is a thing that somebody controls, why doesn't everybody see it at the same time? I don't know.
What are you talking about? Nobody said that.
Okay, well, you were talking about
the eclipse. Drugs?
I'm definitely not on drugs. Nope.
Are you drinking?
I am not.
Then where the hell did you get that from? You can't even answer a simple question on the logical connection between the object in the sky that you see, an observed phenomenon, and why it's connected to the shape of the Earth. It's a simple question. You think it's a foregone conclusion, which is obvious. I'm saying it's not so obvious. So tell me, what's the obvious connection? What would lead you to that conclusion?
You have a good point. No, I'm saying you have a good point, right?
What was the question again?
We don't know. We might not know what it is. We could be assuming everything. I don't know.
Listen, do you think? Listen, even Copernicus, wrote, "We can never attain the true causes. We can only make models and make predictions of past and future events."
Mm-hmm.
Okay, so even he said that, and you're talking about the Copernican model. You can't attain the true causes of events like eclipses, solar eclipses, any of that stuff. Seasons, because they are visuals, right? They're visuals. You just look at them. Can't manipulate them.
How are seasons tangible? Visuals?
They're visuals, so you just see them.
Right.
Have you done anything other than see the moon? Have you done anything other than look at the sun? Have you done anything other than look at Mars, Venus, Jupiter? Have you ever done anything other than just look at them?
No.
Okay, then. So they're just visuals.
Right.
Okay, so with the Earth, we're talking about something that's tangible.
Like seasons.
The Earth is certainly tangible.
Seasons are not. They're not. Right. They're not visual. Seasons are not visual. You can actually like.
Seasons are a correlation theory, and there's two things of seasons. So there's meteorological seasons and there's astronomical seasons, and they're loosely correlated depending on where you live.
Okay.
So meteorological seasons lag what's called the astronomical seasons by some amount. Could be 2 months, could be 3 months. It depends on your climate. So there's a loose correlation there. Right. It's attributed to the tilt of the Earth, but that's probably in doubt because it could also be the length of day. So the exposure to sunlight, the angle of the sun is irrelevant if the day is 3 hours longer, right? So saying it's the tilt and it's the angle that the sun hits the Earth, how is that proven if the sun is actually in the sky for 3 more hours? See, these are like little stories. It's like it's your interpretation. These are philosophical issues. They're nowhere even near scientific. But to get to the matter, the real crux of the matter is what's the shape of the Earth, right? It's not even a science question. It's only a question of measurement. Just like what's the shape of your table? What's the shape of your house? What's the shape of your head? Right? You don't need a scientific theory for that, do you?
Well, because we know.
What's the shape of my table? Well, we come up with this theory.
Well, we know, right?
That's different because
it's different, right?
We know the shape of my head.
It's different than science. It's different than science because it's a different type of question. It's a what is this question? It's not a why is this question.
Okay.
So we can do that with the Earth. We can solve this what is question by just measuring it directly without appealing to theories and hypotheses and just say, hey, let's take a tape measure and figure it out.
Mm-hmm.
People have like.
So we've done that. That's what I don't think you get. We've done that.
Measured it, and like people don't do.
We've measured significant portions over large bodies of water, and there's no measured curve. Multiple times in multiple countries by multiple people using multiple methods.
Okay. Well, I think that there's no measured. Well,
no, there's measured curvature. I guess it's just like depends upon the way they interpret the data that they get.
Yeah.
Well, I'll tell you how they do it.
There's definitely curvature. No, they've measured curvature for sure.
You think so?
Oh yeah.
Measured curvature.
Oh, here we go. I knew I was going to wake your ass up.